In this video, we are going to examine Ethernet MAC addresses. But first, let's begin with the analogy of Talithia wanting to communicate with Jeremy. Talithia and Jeremy are the only two people in the room within hearing distance of each other. So without having to mention Jeremy by name, Talithia just asks, "Hi, how are you?" Jeremy knows Talithia is talking to him and replies also without mentioning Talithia by name. But what if there are more than just two people in the room? Now, if Talithia says, "Hi, how are you?" each person in the room is wondering who Talithia is speaking to. To ensure that Jeremy knows Talithia is speaking to him, Talithia will include Jeremy's name in the message. "Hi, Jeremy. How are you?" Now Jeremy knows Talithia is talking to him and will respond using Talithia's name when speaking to her. Ethernet LANs use MAC addresses, media access control addresses, to accomplish the same thing. Every NIC, network interface card, has a unique 48-bit MAC address embedded into the card, represented in hexadecimal notation. Also known as a physical address, the MAC address never changes and will be the same wherever the device is located. Ethernet MAC address has two parts. The first 24 bits represent the Organizationally Unique Identifier, or OUI. This is the vendor or manufacturer portion of the address. For example, one of several OUI codes associated to Cisco systems is 00602F, as shown in the example. The second 24 bits are assigned by the vendor and unique to that particular OUI. For example, 3807BC is unique to the vendor code 00602F. 48 bits, with the OUI and vendor assigned portions each being 24 bits. MAC addresses are typically represented in hexadecimal, 6 hex. Ethernet MAC addresses are used for NIC card to NIC card communications on the same network. On an Ethernet LAN, there can be multiple devices. Similar to Talithia speaking to Jeremy, when a device on a LAN needs to communicate with another device on the same LAN, it is important that that device includes the MAC address of the destination in the message. Otherwise, the devices won't know who the message is for. When PC A sends a message to printer B, it will send it to printer B's MAC address. Routers on an Ethernet LAN will also have an Ethernet NIC, which means it has an Ethernet MAC address. Notice router D has two Ethernet NICs, one for each network it is connected to. That is what routers do. They connect to multiple networks. Router D's Ethernet NIC, with the address that ends in all Ds, is only used to communicate with other devices on the same network, with PC A, printer B, and server C. Router D's Ethernet NIC, with the address ending in all E's, is used to communicate with devices on a separate network. This NIC cannot be reached by devices on the other LAN, such as PC A. When server C sends a message for a device on another network, it will send the message to router D's MAC address ending in all D's. Router D will forward this message off the appropriate interface towards the destination device.